All right, welcome to another math mini lesson. I know you guys are super excited for some more math. Today we're going to do difference of perfect squares part 2. If you haven't watched part 1, you should definitely turn this video off and watch that first, because otherwise you might end up being a little confused. But we are going to start today with a little bit of review from the last time. So the last time when we talked about difference of perfect squares, we talked about examples like x squared minus 9. And I sort of gave you two different ways that you could look at this. You could look at this as if it was a trinomial with your middle x term being 0. So you put a 0 at the bottom of our x and we put a negative 9 at the top. And we looked for two numbers that multiplied to give us negative 9 and added to 0. In this case, 3 and negative 3. And so we end up with an answer of x plus 3 times x minus 3. You guys did an excellent job with that for those of you that turned in that assignment. If you haven't turned that assignment in, you should definitely do that. But another way I talked to you about doing this is you can think about this as taking the square root of each of these terms. So something like the square root of x squared, that's our x and our x, and the square root of our 9, which is 3 and 3. And we're always going to end up with a plus and minus in the middle. Now, it is important to know that if we were to check this answer, the way that you could check to see that you did this right is by actually multiplying this out. So x times x times negative 3, 3 times x, 3 times negative 3, and you would see that you would get back to x squared minus 9. Now, it's important to realize that this is how you get back there because there are going to be some examples that will not work. So, for example, if we have x squared plus 16. Now, many of you are probably sitting in your house thinking, oh, that's easy. It's x plus 4, x minus 4. Unfortunately, because of this plus sign, that's not going to work. If we try to do x plus 4 times x minus 4, unfortunately, that would lead us back to x squared minus 16. And if we tried something like x plus 4 times x plus 4, that also would not work. That would bring us back to x squared plus 8x plus 16. So no matter what way we try it, this isn't going to work. So this right here is an example of a prime, one that we cannot find the difference of perfect squares in. So if you see something with a plus sign, that's automatically going to be prime if we're talking about just two terms like we are here. All right, we are going to talk today about some slightly more difficult problems that are differences of perfect squares that are not prime. So for example, ones like 4x to the fourth minus 25. Now, when doing this, our x method isn't really going to work because we have things that are bigger than 1 in front of our x. So what we're doing here is we're just going to be taking the square root of each term. So I'm going to start with my 4x to the fourth, and then we'll move on to our 25. The square root of 4 is 2, so I've got 2 and 2. The square root of x to the fourth is x squared. Now I know I'm going to need a plus and a minus. And then the square root of 25 is 5 and 5. So my answer here is going to be 2x squared plus 5, 2x squared minus 5. If I can't take the square root of both terms, then that's going to be something that we can't factor at this moment. All right, let me just give you one more example, and then I'm going to kind of give you a challenging one. Sorry, this video is going to be a little bit longer than our previous ones. So Another one we could do would be something like 100 x to the 4th y to the 8th minus 25 x to the 10th y squared. Now this obviously looks way more complicated than the other examples we've done, but if you take it piece by piece and you just take these square roots, it's not going to be so bad. So I'm going to make my 2 parentheses. Hopefully I don't run out of room. Square root of 100 is going to be 10 and 10. Square root of x to the 4th will be x to the 2nd and x to the 2nd. And the square root of y to the 8th is y to the 4th, y to the 4th. Now I'm going to need a plus and a minus. And I'm going to then do the square root of this final piece here, which is 25 x to the 10th, y to the 2nd. Square root of 25 is 5. So I'm going to put my 5s. Square root of x to the 10th is x to the 5th, x to the 5th. And my square root of y squared is y times y. So that's going to be my answer for this example right here. All right, one more final example, and I'm going to show you how sometimes you're going to have to do this twice. So, for example, if we have x to the 4th minus 81. Now this looks much easier than our last examples. I go to take the square root of x to the 4th, and I've got x squared. I go to take the square root of 81, and I know I've got plus 9 and minus 9. And you're probably tempted at this point to say, all right, I've got my answer and I'm done. However, if we look a little bit closer, x squared minus 9 is another example of a difference of perfect squares. It's a difference, and I can take the square root of both those terms. So in this case, we need to do our difference of perfect squares one more time. So I'm still going to have this x squared plus 9. Can't do anything with this because this would be prime because of that plus sign in the middle. But x squared minus 9, I can take the square root of each piece here. Square root of x squared is x and x. I know I've got plus and minus. Square root of 9 is 3 and 3. Now at this point, I don't have any more difference of perfect squares, so I can stop this here. So this would end up being my final answer for this particular example. All right, sorry, this video is a little longer than the other ones. Hopefully you were able to bear with me. I'll be back tomorrow with another video. Let me know how these are going and if you need any help at all.